So hey nerds, this is Zaman and this is our today's integral. And this is not the standard integrals and we cannot do it by the direct substitution method. So we have to use our mind. Yes, so we have to use something trickier. So if you try to ask the same concept for, I think, ChatGPT, he used the concept of logarithm. So I don't really know about this concept and I did really get confused when I asked the solution for the ChatGPT, but I didn't get the desired result because of this concept logarithm. So I do not have enough concept of this thing. But I asked an alternative way with ChatGPT, and I suggest him, what if we can write this whole bunch of this equation, right? So this equation in summation from that going from some variable number. So it would be an easier to evaluate, and once we get for the normal, once we get the general formula for the summation, and we have to substitute just t squared and we got the desired result. So basically, so if you want to open the expansion, you can actually open it by using Taylor series, Maclaurin series, or the combination of both, we have to say. Yes, and sometimes book refers it's Taylor series and sometimes it refers Maclaurin series, but in more precise I have to say Taylor's Maclaurin series, and it goes like x minus x squared over 2 plus x3 over 3 minus x4 over 4, and it goes on, so on and on. Yes, so we can write it in terms of summation form, and that goes from n equals 1 to infinity. And since you can see from here is alternate positive and negative sign. So in order to encounter for that fact, I'm going to use -1 raised to the power n plus 1. So why I had used it, this you will be understanding in some moment. After n, it is x raised to n over n. So here is not any kind of factorial things. So if you want to substitute, n is 1, you get what? -1 raised to the 2 and simply x, and here 1. Yes, and if you go for n is 2, you get -1 raised to the power 3, and it becomes minus, and you get x squared over 2 plus so on and on. So in general, our equation looks like this. The value ranges from here to there, and since we have t is our function, as more precisely we have to say t squared. So if I substitute x is t squared, I simply get summation that goes from n to infinity and -1 raised to the n plus 1, and it goes like x, we have t squared, so you can write this t raised to 2n over n. So this would be our final form, and now just we got ln 1 plus t squared is this much. So I have my integral I that goes from ln 1 plus t squared, and it is dt, and it can written as integral, and this goes from summation and goes from 1 to infinity, -1 raised to the n plus 1, and it goes like t raised to 2n over n, and it is dt. And if you know the fact that you can take the constant and the unknowing part from the integration, and it goes like summation and goes from 1 to infinity. Yes, we have -1 raised to the n plus 1 over n, and the integrand is just t raised to 2n and it's dt. So finally we can write it like this: summation n goes from 1 to infinity, -1 raised to n plus 1, right? And this is going to be simple power rule formula, 2n plus 1 over n times 2n plus 1 plus some arbitrary constant if it satisfies some initial conditions over there. Yes, and you can see actually from, yes, it is viewable. So finally we calculate our final integral of this is summation where n goes from 1 to infinity. Yes, and we got -1 raised to n plus 1 t raised to 2n, yes, plus 1 over n, and this is 2n plus 1 plus some arbitrary constant of c. So up to there, bye bye, and try to send your problems if you had any problem with calculus. Yes.